In this lesson, I'd like to take a look at what's called arc length, and this is commonly misunderstood. And if you just have a concept for what you're calculating and where it comes from, the formula itself, you don't even really have to have it. You just need to know what it represents, and you can conceptually put this together. So if you're asked to find an arc length, let's say we're finding the arc length from this point to this point, so we might call this A and this B, and if you were asked to find the measure of arc AB, okay, and sometimes you might not have the M there for measurement. It depends on whether you're being asked for an angle or for a distance, but right now we're going to deal with distance. Okay, so if we knew the angle measurement was, say, 115 degrees, we have that information. What we want to know, this is basically asking us, if you don't see this right here, it's going to be asking you for a distance. Okay, and let's take a look at this right here. Okay, we're looking for that distance. Now that's not a straight line, so that's what makes this hard. We've got a formula that we put together to calculate this, but you can't just look at it and know. I know we have a distance right here of 5, and that's related to it, but that's not it. Okay, it's a curved length, which makes it difficult to measure. If you had a piece of string, you might be able to lay it along that circle and figure it out, but in most cases we have to do it conceptually. Now let's take a look at something you guys learned quite a while ago. The distance all the way around a circle. Okay? That's called the circumference. And circumference is 2 times pi times the radius. That gives us the distance all the way around. Well, hopefully you recognize that this right here is the same as that right there. Okay? So when I'm finding the arc length, I'm finding the distance around the circle. But I'm only finding a piece of it. And this right here is basically asking you how much of the circle you're looking at. So if I look at what I have now, I know this says n over 360. What you really need to know is it's asking you what that central angle is. Like what's the piece of the pie, basically. So what I have is I have 115 degrees out of 360 in the whole circle, and that little ratio, that fraction or that decimal, that percentage, however you want to look at it, I'm going to take that little chunk, okay, that piece of it, which is less than 1, it's less than a full circle, I'm going to multiply it by 2 times pi times the radius, and that's it. That'll give me the length of that arc. So if I want to find this arc length, it's going to be 2 times pi times the radius, which happens to be 5, times that value. Now for some people you might want to just turn that into a decimal. So if I took 115 divided by 360, this right here basically turns into 0.32. And that number just means I'm only looking at 32% of this circle. That's it. And you can kind of look at the picture and go, yeah, that looks about right. That's a little less, that's around a third of the circle. So yeah, seems reasonable. So I'm basically saying, here's the entire distance around the circle, which happens to be 10 pi if I multiply it together. But I don't want the whole circle, I just want 32% of it. Okay? So if I do that, 10 times pi times 0.32, I'm going to get 3.2 pi, or 10.04 units. And once again, I'm not doing square units because I do not care about the space in this circle. I'm looking at the distance right here. So it's a linear measurement. Okay? 10.04 units.